Hey everyone, this is Math Done Right, and today we're going to be solving quadratic equations by factoring. Now, a quadratic equation is any equation of the form ax squared plus bx plus c equals 0, where a is not 0, and b and c can be any number they want. But if a is equal to 0, then this term is gone and we get a linear equation. So that's why I need to make sure that a is not 0, so that way we get a quadratic equation. And like I said, today we're going to want to solve these equations by factoring. So that means we're going to have something that looks of the form ax squared plus bx plus c equals 0, and we want to break down that equation into different factors and solve that way. Alright, so I'm going to go through a few different examples of problems that would be considered factoring. So let's look at this first one. Example 1. Let's look at the equation x squared minus 3x equals 0. And notice that it is a quadratic equation because I have an x squared term. And so if I look at both of these terms in this equation, I notice I have an x in both of them. So what I can do is pull out an x from both terms. And when I pull out an x, what am I left with? Well, when I pull an x out of x squared, I'm left with an x. And then when I pull an x out of minus 3x, I'm left with minus 3 equal to 0. Now this is the format that we want all these equations to end up looking like. We want something times something equal to 0. And when we have that, we're going to get that this factor is equal to 0, and then that this factor is equal to 0. So when we do that, we get x equals 0, and we don't have to solve anymore, and that gives us one solution. And then the other factor we get is x minus 3 equals 0, which gives me that x equals 3. And those are my two solutions to my quadratic equation I have. And I can check them really quick. If I do 0 squared minus 3 times 0, I get 0. And if I do 3 squared minus 3 times 3, I get 0 again. So it's really easy to check your solutions too with these kinds of things. Alright, so now we're going to look at a different kind of example. Let's look at the equation x squared minus 16 equals 0. And this one is going to be an example of a difference of perfect squares. Difference of perfect squares. So what that means is that I have a difference, so I have a subtraction going on here, and x squared is a perfect square because it's x times x, and 16 is a perfect square because 4 times 4 gives me 16. And anytime I have something that looks like that, so for example, let's say I have something like x squared minus, just let's say blah squared, that's going to be equal to x plus blah times x minus blah. So I look at the two numbers that give me the square here, which is going to be blah and blah. And like I said, for 16, that's 4, because 16 is 4 squared. So this gives me that x plus 4 times x minus 4 equals 0. And just like I did with the last example, that's going to give me my two solutions, x plus 4 equals 0 and x minus 4 equals 0. And I just solve for x here and I get x is negative 4 and x equals plus 4. And it's easy to check really quick. If I square 4, subtract 16, I get 0. If I square negative 4, the negative becomes a positive, and then I get 16 minus 16 gives me 0. So that's called difference of perfect squares. Alright, example 3. we're going to look at x squared minus 5x equals negative 6. And remember from the intro that I want to have everything equal to 0. So the first thing I'm going to do is add 6 to both sides. And that's going to give me x squared minus 5x plus 6 equals 0. And now I can solve this thing. So with something that looks like this, where I have an a, b, and a c term, I want to look at my a term, which is technically a 1, and my c term. So I have a equals 1, b equals negative 5, and c equals 6. So I want to find two numbers that give me a times c and add to give me b. So I want two numbers that multiply to give me a times c, but when they add together they give me b. So let's look at the factors of 6. So if I look at 6, I have 1 times 6 equals 6, and 3 times 2 equals 6. Okay, well neither of those add to give me negative 5, but what if I make everything negative? Negative 1 times negative 6 still gives me positive 6, but they don't add to give me negative 5. Ooh, whoops, I wrote a 2 here. This should be a 6. But negative 3 times negative 2 gives me positive 6, and negative 3 plus negative 2 gives me negative 5. So these are the two numbers I'm going to look at. So now what I do is this equation is now going to be made from these factors. So it's going to be x minus 3 times x minus 2 equals 0, which gives me that x minus 3 equals 0 and x minus 2 equals 0, which means that x equals 3 and x equals 2. And these are my solutions. Alright, example 4. And this one is going to be an example of a factor by grouping. And I use this when a is not equal to 1. Use when a does not equal 1. The last example, a was 1, but this one we're going to look at 2x squared minus 5x minus 3 equals 0. And here we have that whoops, no comma, sorry. I have a equals 2, b is negative 5, and c is negative 3. And I'm going to do a similar thing to what I did last time. I'm going to look at what a times c is. So a times c is 2 times negative 3, which is negative 6. So I want two numbers that multiply to give me negative 6, but then I want them to add to give me the b term once again. So I look at the factors of negative 6. Well, I have 1 and 6 and 2 and 3 and a minus on either the 1 or the 6 or the 2 and the 3. And I want them to add to give me negative 5. So the way that's going to work is if I make the 6 negative and then I add 1 to it. Right? 1 times negative 6 gives me negative 6, but 1 plus negative 6 gives me negative 5. So those are the two numbers I'm going to look at for this one. Now what I'm going to do is rewrite my equation using these two numbers here, and this is the way I'm going to do it. The 2x squared is going to stay the same, but now I'm going to add an x, subtract a 6x, and then the minus 3 stays the same. And if I compare these two, it's the exact same equation, I've just rewritten it a little differently. Now, this is where the grouping comes in. I'm going to look at these two terms and these two terms and try to pull out as much as I can from both of them that are in common. So in this term, the only thing I have in common between these is an x. And when I pull out an x, I'm left with an 2x plus 1. Now, between these two, I'm going to pull out a minus 2, and I'm left with, or minus 3. Let's make that look more like a 3. Whatever, that's a 3. And what am I left with? A 2x plus 1 equals 0. And this is good because we want these 2x plus 1s to be the same. Because now what we can do is factor these out from both terms. So when I do that, I get a 2x plus 1. And when I factor that out of this term, what am I left with? An x. And when I factor it out of this term, I'm left with a minus 3 equals 0. And now I can do what I've been doing this whole time. This gives me that 2x plus 1 equals 0 and x minus 3 equals 0. This one's easy, gives me x equals 3. And this one's going to give me that x equals negative 1/2. And that method was called factor by grouping. And this is, the grouping comes from, right, I group these two terms, I group these two terms, and I want to make sure what's inside of here is the same. That's the point of this. If they're not, I can't factor them out. And so you have to make sure you pull out the right stuff. If I would pull out a plus 3 here instead of a minus 3, I would have been off a little bit, but then I could have been like, oh, I just pull out a negative and then it'll work. Okay, well, that's all I have for solving quadratic equations by factoring. Make sure you guys like and subscribe, share with your peeps. Thanks for watching. Bye.